Hello, Gohar.
Hi.
Hi, yes. So we will be soon starting the presentation. So you want to stay in the background, and then once we finish, you would be able to answer the questions from the audience. Is that all right?
Yes, that sounds great.
Okay, great. So I'll keep you online over there, okay? Thank you. Okay, let's just, wait a minute. So Dr. Olena Dubovyk, she is working at the University of Bonn. She has extensive research experience in the application of Earth observation techniques for drought monitoring as well as agricultural monitoring and modeling. She has developed methods and tools to assess land degradation based on multiple remote sensing data and different spatial scales, including regional, provincial, and field level. Olena also is currently a principal investigator in the project called Evidence, which aims to contribute to the national monitoring system in the field of drought risk. It includes applications in agriculture. The research work is carried out by ZFL in collaboration with UNU, EHS, and UN SPIDER. Olena also teaches at Geography Department at the University of Bonn and has more than 15 peer-reviewed publications in high-impact journal. So we will start the presentation with Olena.
Good morning, everybody. My name is Olena Dubovyk, and I'm coming from the Center for Remote Sensing of Land Surfaces. Together with my colleague, Gohar Gazaryan, today we are going to present for you an important topic of geography of drought hazard and risk, and why it is important to do both drought hazard as well as a risk assessment. I'm going to be with you for the presentation, and my colleague Gohar Gazaryan is going to answer all your questions that you may have after this presentation. So, the outline of this talk, we will start with a short introduction to the problem of the drought, why it is important to study droughts. We are going to look at the key definitions of the droughts as well as concept. Then we will move to the methodological approaches towards drought hazard and risk assessment, and I will provide you with a very brief overview how we can do drought risk and hazard assessments. And finally, I'm going to showcase the drought hazard and risk assessment with different examples from global as well as regional scales. And finally, I will summarize this presentation with a summary and outlook. So there is no doubt that drought is a global problem with profound implications on both environment and people. Few recurring and extreme natural events are as environmental, economic, and socially disruptive as droughts, which affect millions of people in the world each year, irrespective of their geographical location. So if you are going to look at this slide, you can see that drought does not respect borders. So we have affected both developing and developed countries with the millions of US dollars in damages caused by the drought. Due to the growth of population and expansion of agricultural, energy, and industrial sectors, the demand for water has increased manifold, and even water scarcity has been occurring almost every year in many parts of the world. Other factors such as climate change and contamination of water supplies have further contributed to the water scarcity. In recent years, droughts have been experienced with higher peaks and severity levels, as well as due to climate change. We have observed the increased frequency of the drought event in different parts of the world. So there is no doubt that the issue of the drought is worthwhile studying and looking at it more carefully. same time, drought is probably one of the most complicated conceptual issues to deal with due to the differences in views and disciplinary approaches that could be used to study the droughts. Well, drought definition is basically the starting point which we have to look at, and so the question of the drought definition is also very complex, which reflects the complexity of the drought. Research in early 1980s uncovered that more than 150 published definitions of drought exist. The definitions reflect differences in regions, needs, and disciplinary approaches. So let's have a look on some of these definitions that I have summarized for you on this slide. One of the commonly used definitions from United Nations Secretariat General refer to the drought as to a naturally occurring phenomenon that exists when precipitation has been significantly below normal recorded levels, causing serious hydrological imbalances that adversely affect land resources production system. At the same time, Food Agricultural Organization refer to the drought as the percentage of years when crops fail from the lack of moisture, while World Meteorological Organization define droughts as a sustained extended deficiency in precipitation. So basically what I'm trying to say with this that there is no universal definition of drought, and drought definitions vary depending on the variable used to describe the drought and reflect differences in regions, needs, and disciplinary approaches. Many disciplinary perspectives of drought exist. Each discipline incorporates different physical, biological, and/or socioeconomic factors in its definition of drought. Because of this, numerous and diverse disciplinary views, considerable confusion often exists over exactly what constitutes a drought. One of the most frequently referred to typology of the drought is the one which was introduced by Wilhite and Glantz back in 1985, who categorized definition of drought in terms of 4 basic approaches to measuring the drought. As you can see from this figure, those ones are meteorological, hydrological, as well as agricultural and socioeconomic droughts. This also reflects a disciplinary perspective towards the drought. The first 3 approaches deal with the ways to measure drought as physical phenomenon, while the last deal with drought in terms of supply and demand, tracking the effects of water shortfall as it ripples through socioeconomic system. So let's have a closer look towards each of this type of the droughts. First of all, meteorological drought. Meteorological drought is usually defined as a lack of precipitation over a region for a certain period of time. Agricultural drought, at the same time, usually refers to a period with a decline in soil moisture and consequent crop failure without any reference to surface water resources. Hydrological droughts is related to a period of time with inadequate surface and subsurface water resources for established water uses of a given water resource management system. And the final type of the drought is a socioeconomic drought, which is usually associated with failure of water resource systems to meet water demands, and thus associating droughts with supply and demand for an economic good, which is water. So this was the 4 main types of droughts, and let's move to further terms such as drought hazards, weather, drought versus drought risk assessment. So drought risk is usually defined as a function of 3 elements, which is drought hazard, drought exposure, and vulnerability to droughts. So let's now talk independently about each of the elements of the drought risk. drought hazard is the first one is usually defined as a drought events that may have adverse effects on vulnerable and exposed elements such as meteorological droughts, agricultural droughts, and hydrological droughts. At the same time, exposure is basically an inventory of elements such as population, its livelihood, and assets in an area where drought events may occur, while vulnerability is defined as a predisposition of exposed elements to suffer adverse effects when impacted by a drought event. And so risk is constitutes three these elements: drought, hazard, exposure, and vulnerability. Well, the issue of the droughts has been recognized on a broader scale, and in order to reduce the global threat of the droughts, an increasing number of both international as well as national initiatives have begun to encourage all the governments around the world to move towards a drought-resilient societies. Just to name few of those initiatives, for example, United Nations Convention to Combat Desertification around 2 years ago has introduced a new focus beside of land degradation on droughts in order to address the importance of the rising issues and impacts of the droughts. Another conventions and agreements to mention is Integrated Drought Management Program from 2013, Paris Climate Agreement in 2015, Agenda 2030 for Sustainable Development, as well as Sendai Framework for Disaster Risk Reduction. What is common of all these international initiatives is that they emphasize a need on a shift from crisis management to so-called disaster risk management, which promote proactive disaster risk reduction strategies at different scales, including drought risk reduction strategies. What is a precondition of those proactive disaster risk reduction strategies, as well as implementation of the shift from crisis management to disaster risk management? Basically, the precondition is an improved understanding of disaster. In our case, it is drought. And this was also documented in international framework. So, for example, Sendai Framework for Disaster Risk Reduction put it as a priority number 1 for action of Sendai Framework. And what do we need to have this improved understanding of droughts? Well, for this we have to know the special patterns of occurrence as well as the characteristics of the drought. So there is currently a research need in specially explicit drought hazard as well as drought risk assessment and different spatial and temporal skills. And now let's move to the following section, which show you in a brief overview how exactly we can do and implement drought risk and drought hazard assessment. To start with, there is always a conceptual framework where we conceptualize our problem. Based on this, so drought risk assessment, the potential indicator set to characterize drought risk as well as drought hazard is defined. This preliminary set of indicators is basically guide the data collection for the indicators as well as based on the collected data. Regarding drought hazard indicators, which could be used for drought hazard assessment, there are numerous of the indicators which were developed by far. So a good overview of the existing indicators from different perspectives could be found in the Handbook of Drought Indicators and Indices, which is published by World Meteorological Organization in 2016. Those drought indicators are used to provide quantitative assessment of the different characteristics of drought events, including its severity, location, timing, as well as duration. In the Handbook of Drought Indicators and Indices, there are 4 categories of indicators and indices, which are referred to meteorology indicators and indices, soil moisture, hydrology, remote sensing, and composite or modeled indicators. And consequently, drought hazard assessment could be conducted based either on a single indicator or using multiple indicators. Looking at the drought vulnerability indicators, those vulnerability indicators are used to calculate vulnerability index, and drivers of vulnerability are numerous. They are both social as well as environmental, so our vulnerability indicators also reflect this issue. Well, there are different categories of vulnerability indicators, and one of their typology presented on this slide is categorize vulnerability indicators into social environmental indicators, acceptability, coping adaptive capacity, ecosystem robustness. And how we do this? We use literature review, expert meetings, or surveys. And now let me show you different examples of drought hazard and risk assessment. And let me start with a global drought hazard map. So this is global meteorological drought hazard map. So the authors, which is Karao et al. From 2016, used meteorological definition of meteorological drought to guide his assessment. He used monthly precipitation totals as the input data. The method used to compile this map is a weighted anomaly of standardized precipitation deficit index. He applied mask for hyper-arid and cold areas as well as water bodies, so those areas were masked out from the assessment, and the period analyzed was quite long, from 1901 till 2010. Let's now look and talk a little bit more about the results. So the map, which you can see, highlight less hazardous areas in terms of the drought hazard in blue and shades of blue, while red and orange shades shows more hazardous areas. So how drought hazard areas were found in Eastern and Southern America, in Central Asia, in Australia, for example, while low drought hazard areas were located in the Amazon, Central Africa and Southern Asia, Northern Europe, as well as Central and Northwestern Russia. My second example is again at the global scale, and the same authors have computed not only a meteorological drought hazard map, they also computed a global drought risk map. And for this, they used a variety of environmental, infrastructural, as well as socioeconomic data sets. Method used was indicator-based computation and overlay of drought hazard exposure and vulnerability. They also apply the same mask as in the previous example, and the time period analyzed was a little bit different. So for drought hazard, they use the same period as in the previous example, but the exposure and vulnerability was computed from 2000 till 2014. The results have shown high drought risk areas, which were located, for example, in Southern Africa, in southern part of the South America, in Central Asia, in Europe, across India. While low drought risk areas were found mostly on the most of North and Central America, in the Northern Europe, Central Russia, as well as Australia. The next step was actually bring those two assessments in the same slide and to compare drought hazard assessment versus drought risk assessment. So let's see what we actually have found. Well, just looking at this example, we can see that there are western coast of the United States of America, California, for example, were identified as the more hazardous areas in terms of the drought hazard. At the same time, the drought risk map showed an opposite result, so the same areas were identified as a lower risk areas in contrast to the drought hazard. The same was true for the southern part of Argentina, which was identified as more hazardous areas in terms of the drought hazard, and risk was found as low to medium within these areas. Another example from India and Southeast Asia, we see that in terms of the drought hazard, these areas were identified as less hazardous areas, but at the same time, drought risk was higher in these areas. So basically, what I'd like to tell with this is that this example showcase that we could have an opposite results when we do just drought hazard assessment or drought risk assessment, and it is important not only to look at drought hazard but go one step further and compute drought risk, because only guiding decisions based on the drought hazard maps could be misleading. My second example is from a different type of drought. So now we are going to look at the agricultural drought hazard map, which was computed based on the monthly precipitation totals. Other inputs for these maps were gridded crop maps, crop calendar data, as well as global irrigation map. The method used was the drought hazard index as well as standardized precipitation index, and there was a crop map applied as a mask for this map. Time period analyzed was from 1980 till 2008. The results showed high drought, agricultural drought hazard areas in red and yellow colors, and while green and light green color shows the low hazardous areas. So in terms of the high drought hazard of agricultural drought, the areas were found in central United States, southern east of South America, Europe, as well as across southwestern Russia, while low drought hazard areas were found in central North America, most of Central America, northwestern South America, as well as north central Africa and northern Kazakhstan. And let us now look at those two different drought hazard assessments. So let's compare meteorological drought hazard map as well as agricultural drought hazard map at the global scale. So interestingly, what we can see is that in some parts of the world, both maps agree well. For example, for Central America and India, both maps has agreed that it was low to medium hazardous conditions, while there were also some areas for which those two maps disagree. For example, most of the Europe in the first assessment was marked as less hazardous area, and the same area was identified as high to very high hazardous areas in agricultural drought hazard assessment. The same results we achieve when we look at the Southeast Asia. So basically, the results are contrasting. What does it mean? It means that we also have to bear in mind the differences which we can in the result of our assessment, which we can get when we use different definitions of the drought. So the careful selection of the definition of the drought is very essential, because it will lead consequently to the different results of the assessment. So again, highlighting how important is conceptualizing and correctly conceptualizing the problem of drought. And now I'm going to go on the regional level and show you some example of our work which we have been doing in South Africa since now already some years. So the example which I would like you to show is located located in Eastern Cape Province in South Africa. This is the second largest province in South Africa with an area of more than 170 square kilometers. Its population is around 13 million people. And this area also characterized by very pronounced gradient. So we have a gradient stretching from northeast and east from about 800 millimeters and to 1000 millimeters per year in the northeast and east to about less than 400 millimeters down in west and south. The temperature also has a pronounced gradient with more mild winters and temperatures along the coastline, so basically it's here, and harsher winter conditions along the western border of Eastern Cape, where the mountains are located. In terms of land use, well, basically for those of you who are not very familiar with the South African tenure system, we have two different systems. We have commercial and communal farming. And in terms of the land uses, Eastern Cape is usually characterized by livestock production, so it's not crop production. Mainly, most of the area is a natural veldt, so comprises 84% of the area, and it's used for livestock production. The cropping is practiced only on 8% of the area. Average farm size is around 18 hectares for communal farms, and please notice that most of the communal cropland areas are located here on the northern part of the Eastern Cape, while most of the commercial farms are located here in the south and southwest. So our task was to compute a livestock drought hazard and risk assessment for 3 selected districts within Eastern Cape Province of South Africa. So the selected districts was OR Tambo, Jogabi, as well as Kakadu district. Now, OR Tambo is a district which receives the highest precipitation within Eastern Cape, so up to 1000 millimeters per year, while Jogabi is a good example for altitudinal gradient because of the proximity to mountains, and Kakadu region is a region with the lowest precipitation amount among those 3 districts. So the first map which I would like to show you is a livestock sector drought hazard map, which was computed on the sub-district level, and the hazard index values ranged from low in blue shades on the map to extreme and severe with red and orange shades on the map. So clearly the results showed that most of OR Tambo, Jogabi, as well as the pockets of Kakadu were described as moderate to extreme hazardous areas in terms of the drought, while less hazardous areas were found in the pockets of Kakadu district. Having done this, the second step was to compute actually a livestock sector drought vulnerability map, which was done based on more than 30 different vulnerability indicators, and the resulting map actually is quite different from the hazard map. So what we immediately can see that most of our OR Tambo district was characterized as an extreme vulnerable area towards the droughts, while the less vulnerable area was Kakadu district. And the reasons behind is several, but one of those reasons is that Tambo is basically the highest, has the highest density of population among the three analyzed districts, as well as this is the most poor area with communal farming prevailing within Tambo and ongoing land degradation issues, while Kakadu district is a district where most of them large commercial farms located in Eastern Cape. And my final map is about livestock sector drought risk map, and it's a kind of a mirror of vulnerability map. So the final result showed that the highest drought risk is found in Tambo, followed by Jogabi, which was characterized by moderate to severe mostly values of risk, and the least low to moderate low risk areas were found in Kakadu. And the most interesting result, and why it is so interesting, those results are because the highest drought risk areas were found actually in the area with a higher rainfall amount. So highlighting this problem that drought hazard assessment could be actually misleading if just only used solely for decision makers. And at the same time, we can see that vulnerability assessment is an essential element of drought risk. So without doing vulnerability assessments, it is the information that we have about the drought analysis are not complete. And for example, I can draw your attention to this area here in Kakadu district. If you look at the hazard map, you can see that there were pockets of severe to extreme drought hazard values. But when we'll move to the vulnerability map, we can see that there is already low to moderate low values of drought vulnerability here, and as a result, our final drought risk map has also low values within these areas. And of course, this kind of information is very vital for decision makers, for local disaster national disaster risk reduction agencies that use this information to activate, for example, safety nets, and to also act when drought occur. So to summarize this talk, without any doubt, drought is a complex phenomenon with pervasive socioeconomic and environmental ramifications and diverse impacts. Understanding, defining, assessing, and monitoring, forecasting, and managing drought is also complex due to the variety of temporal as well as spatial scales at which drought occurs, as well as the diverse direct and indirect causes and consequences of droughts. There is no one-size-fits-all drought definition or indicator set for drought assessment, leading to the differences in the results of drought hazard and risk assessment. And there are currently already operational tools and methodologies for drought hazard and risk assessment that we can use in order to compute both drought hazard as well as drought risk assessment. And I would like again to highlight the importance of drought risk information as opposed to only drought hazard information for effective drought management plans as well as disaster risk reduction strategies. So doing only drought hazard assessment is of course very essential step, and it's also a prerequisite for successful drought risk assessment. So the drought risk information cannot be complete without a reliable drought hazard map, but at the same time to base the decision or policy actions only on drought hazard information could be misleading, as I have demonstrated to you based on both global example as well as a regional example in eastern province of South Africa. That's it. Thank you for your attention. And of course, we are happy to answer any questions that you would have.
Thank you very much, Gauhar. Thank you. We would like to thank Olena, but she's not around. So now that was an excellent presentation. Thank you, and it was quite insightful. We could learn a lot about water extremes and how it differs based on location. We have also seen that the differences between hazard map and when between vulnerability and risk maps. So I would first open the floor for to the audience to see if they have any questions, and then maybe I'll ask you something that's in my mind. Okay, so yes, the floor is open. Oh, that's can you reduce the volume a little bit, please? Yes. Oh, sorry. Yeah.
Hi, good morning. My name is Cesar. I have a question. I want to know the main difference between hazard, vulnerability, and risk. Can you hear me?
Yeah, so as you've seen already, the hazard is just the event that the drought event that might have a adverse effect on the vulnerable and the exposed elements. But the vulnerability and exposure are the other two important components. So with the vulnerability, we have the information how sensitive these exposed elements are. So it's about susceptibility and also coping capacity. So as an example, imagine if there is a farmer who have some farmers who have access to irrigation and some farmers who have no access to irrigation. Of course, those which have no access to irrigation, they will be more susceptible to the drought impact. And also coping capacities, for example, if a farmer has higher income or some alternative income, they will have more coping capacity. So that's an example for the vulnerability. And the exposure element is the people, but not also the people, property, livelihood, and the systems that might be affected by the drought. So, and all these three, the hazard, vulnerability, and the exposure, are the forming the risk itself.
Any more questions? Come on, cheer up, people. She's happy to answer your questions. Yes, Professor. Professor Mario Mandiondo.
Well, good morning, good afternoon.
Good morning.
Where I am here. Here. Hello. When I visit the Joint Research Center in 2015, I met a group working with drought management. And of course, the presentation about different kinds of droughts are important to declare what kind of hazard, vulnerability, and of course resilience we can achieve. The question is, my question is related to time, and specifically about what kind of systems we can offer to the society to make a prediction that perhaps in the next months or even years we are going to face a big or a bigger drought, especially because the experience of the Mediterranean, of the southern part of Europe, is regional, but we have cases in western United States or even in northeast Brazil. So the question is about time and about prediction. What kind of systems of alerts we can introduce physically for the society to be prepared in these different contexts? Again, Southern Europe, Western United States, and Northeast Brazil, because the people are very different in terms of preparation the preparedness are different. The cultural issues are different, and the economy of public policies are very, very different in these three cases. So what's your opinion about this topic? Thank you.
That's an excellent question, and actually it highlights the hot topics in the discussion about the hazard monitoring and risk monitoring. And I mean, of course, these hazard monitoring systems and also alert systems are established in some of the countries with the very conventional data sets such as rainfall and SPI, and then with the modeling they can have some predictions. But from the modeling and the predictions, I would like to come back again to the monitoring systems and having enough data, enough historical data to establish the model itself. So even for early warning and for modeling, we will still need to have enough both ground data and satellite data to have a sound model for that. But of course, with the launch of several sensors, such as the Sentinels from ESA and also the other sensors with MODIS and Landsat. Now, I think from the Earth observation side, we are in the golden age, so it can give enough data for even early warning itself. But again, especially if we look at country-wise, we would need also socioeconomic data. Especially for the vulnerability and exposure analysis, we would need much more data which are coming from the ground. So,
thank you, Gaur. That you summarized the question that I was supposed to ask you as well. Professor asked a very good question, and you have answered it very holistically. I think any other questions? Did you think about why? Yes, please. Yeah, one hand. That's good.
Hi, good morning. I'm Christian. I would like to know how politicians are using the information that you are gained with the whole studies that we have around the world about it.
So the question is about how politicians are using this data. So very like a $1 million question, I guess. What do you think about it, Gaur?
This is a great question. Well, I mean, of course, this information, it depends in different countries. So if you look at the country-wise or district-wise, of course, some of the information is used. And when there is a drought alert, also from the ground, there are safety nets, some policies which would help farmers or exposed people and so on, keeping the prices down. But of course, it's different. And in the global scale, that's another level where also international conventions and international organizations target drought and hazard and risk monitoring as well. But yeah, I mean, the question is how they use this information often is open. There are policy briefs which are usually published. It's not only the scientific output, but there would be policy briefs, information which is more easy to understand. But researchers, scientists cannot force the policymakers to use it. Sure. We wish that they would use it, but
I guess that's one of the bigger questions of this century, the missing link between the scientists and the policymakers. We always start our presentations by saying that there's a need for this, the research outputs that we are producing. We are working hard on that, but often they just sit in our libraries and they don't reach where they should reach. At the end of the day, we are working for the people, and it does not reach the people, and it doesn't have the impact that it should have. So I guess you answered the question very well, and I wish we all had the answer for that. So excellent question, and thank you very much, Gohar. Any other questions on the floor? She's still available. I think if there are any other questions, we have your contact details, and we will send you if some burning questions comes up. Okay, thank you very much. Shall we give her another round of applause, please? Thank you so much, Gaur, for joining us, and we would like to also thank Dr. Dubovyk. Unfortunately, she's not available, but from our side, please thank her and for her excellent presentation. Thank you very much.
Thank you.